Hey, chemistry. We're going to talk about the second part of types of reactions today, predicting products. So, in the last video, we talked about how to look at the unique part of the reactants in order to identify the type of reaction it is, in order to classify the reaction. So, now what we want to do is we want to look at the unique part of the products so that once we identify the type of reaction we have, we can turn that around into actual formulas that will form from that reaction. Okay, so here's where we left off on our last table. We are able to classify the types of reactions. We are able to identify unique features of the reactants in order to identify the type of reaction. So now what we want to do is we want to look through the same list and look for unique features of each of these types of reactions as far as their products go. So this would be a really good place to pause the video and see if you can pull out what is the thing that is unique about this reaction that is true for this type of reaction, but not any of the other four, that I can use and tell you, yes, this will be my product. So pause here, try to do that for the 5 types of reactions. Okay, so for synthesis reactions, the unique thing about their products is that it is one compound. Now, this compound can be covalent or ionic, and so we'll talk about the products that come out of that in just a little bit. But you'll notice that none of the other ones result in one product. So as soon as you identify a synthesis, you know you're going to take the 2 reactants, smash them together, and they are going to make up the compound that will be your product. Okay, decomposition. You're going to result in 2 or more things. Now, this is as vague as it sounds, similarly to how vague the reactants of the synthesis reaction could be. Remember, those things could be elements, those things could be ionic compounds, those things could be molecules, or the covalent bonded molecules. Same thing here. In the decomposition, we can get the same thing. We can get elements, we can get ionic compounds, we can get the molecules or the covalent compounds. And we'll talk more about how to deal with that later also. Also notice that these 2 things that you get, 2 or more things, they were a part of your original compound. So you're not going to invent anything new in the decomposition reaction. You're not going to insert an element that wasn't there before. All your products will be made out of elements that were there as reactants. They're just going to be rearranged. Okay, single replacement reactions. Notice that you started with an element and an ionic compound. You're going to end with an element and an ionic compound also. But you're going to end with a different element. Notice we started with element A. We're going to end with element B. Where did element A go? Well, it's now the cation in your compound. And where did B come from? Well, B was the cation in your compound. So we know that the cations just switch, and cations, remember, are always metals. So the 2 metals in this reaction just switch places. So these are going to be new. Remember, you're not just going to repeat the ones you had before. Similarly, in the double replacement reaction, we had 2 ionic compounds. We are going to end with 2 ionic compounds. But again, they're going to be different. So let's look at how different they are. Notice A was with B, but it's now with D. So same idea, the cations and the anions switch to form new cations with new anions. And then B and C are going to go together as well. And we'll talk about forming those compounds in a little bit as well. All right, so for combustion reactions, we're going to have some type of fuel along with elemental oxygen. And then if your fuel is a hydrocarbon made out of carbon plus hydrogen, the thing you're going to get out is always water and carbon dioxide. If the thing you have is a metal plus elemental oxygen, the thing you get out is going to be an ionic compound of that metal and oxygen balanced against each other. So this one down here, a combustion reaction that involves a metal, it's more like a synthesis reaction where you end up with one compound and you have to consider how to balance that. You can technically classify it as combustion because one of the reactants is elemental oxygen. But when you're looking at the products that form, if it's a hydrocarbon, you're always going to have water and carbon dioxide. If it's a metal that you're burning, you're always going to end up with an ionic compound that involves that metal with oxygen. Okay, so those are the unique features involved in all of the products for these 5 types of reactions. Now we want to return to that list that we classified before, and we want to try to predict the products that are going to come out of this. All right, so as you're predicting products, here are the steps. Step 1, you're going to look at the reactants that you have. Let's say we do have, let me give you a specific one, like lithium and zinc chloride. Okay, so we're going to look at the reactants. We're going to classify the type of the reaction. I have an element plus an ionic compound. This is going to be a single replacement reaction. Now we're going to think about what this type of reaction produces. So I know for a single replacement reaction, that I'm going to produce another element plus another ionic compound. Lithium and zinc are going to switch. So I'm going to form my new element will be zinc all by itself. And then my new ionic compound that I know I'm going to form is going to be made out of lithium and chlorine. Now, here's the tricky part. You have to think about formulas at this point in time. If you form an element, you have to think, is that element going to be monatomic or diatomic? If you form an ionic compound like we're about to do with lithium and chlorine, you're going to have to balance that compound. So lithium is a 1 plus, chlorine's a 1 minus. So I'm going to get lithium chloride, LiCl, one of each. If you have an acid, you're going to have to balance those too. If you have molecules, these are the hardest ones to predict. So in real life chemistry, you're either going to write the molecule that you form from a name that's given to you, or you'll name them because you're familiar with the reaction, or you're going to have to run through some analyzation techniques like photoelectron spectroscopy and mass spectroscopy and a spectrophotometer. You're going to have to use a bunch of analyzation techniques to figure out what you just made so that you can write it in your formula. Now, obviously, we're not going to do this. We'll talk about some of those techniques once you take AP Chemistry next year, but we're not going to go through how to identify the molecule you just formed. So either you're going to be familiar with the reaction because we've dealt with it in lab or something like that, or we will be giving you the name of the compound and you can write the formula from the name. Okay, so this is tricky. We're putting everything together. We're going to put this new stuff with predicting products and identifying types of reactions, along with this old stuff of types of reactions, identifying the type of reaction, the formula, the name. We're putting all of this together. So this is a lot, and you're going to get better at this through practicing. So let's go through a couple practice problems together, and then you can work on some on your own as well. So I'm returning to this sheet that we classified the other day, and let's just go through a couple of these. Okay, so now would be a good time to pause and see if you can predict the products and see how far you can get before you ask a question or use resources. So pause and try some of these now. All right, let's go through some of these together. So this first one we decided was single replacement. So just like the example we just did, the metal and the metal are going to switch places. So my new element I'm going to get out is magnesium. Magnesium is not one of my diatomics, so I just write Mg. My new ionic compound that I'm going to get out is going to form from sodium and chlorine. Now it is going to be an ionic compound. I have to consider charges before I balance the formula of the compound. So sodium is going to be Na+, chlorine is Cl-. I just need one of each, so my new compound is NaCl. So this is the skeleton equation. So notice the equation's not balanced, but all the formulas inside my equation are balanced. Let's do another one. All right, 7 is going to be a double replacement reaction. So the ions are going to switch place. My cation here will connect with my anion here. Again, I'm forming two new ionic compounds. I know that with a double replacement reaction, my products are going to be two new ionic compounds. So calcium is a 2+. Carbonate is a 2-, so CaCO3 will be one of my formulas. And then potassium and chlorine will form. Potassium is a 1+, chlorine's a 1-, so I will get KCl. I've gotten kind of easy ionic compounds so far. They won't always be 1-to-1, so you do need to consider what the ratio will be and balance them. Okay, let's skip down to 11. I want to do 11 with you. So we know 11 is a decomposition reaction. Now, decomposition reactions are super hard to predict what they're going to be because, like I said, you either have to be familiar with the reaction and know what it's going to break up into, or you need to run through some analyzation techniques to figure that out. So for now, whenever you run into a decomposition reaction, just break it into elements. Let me say that one more time. Whenever you run into a decomposition reaction, for now, just break it into elements. Now, if you are familiar with the reaction, if we do the reaction in lab, it's something you work with, then that's a different story. You should be familiar with that reaction and be able to tell me what the products are. But if we haven't dealt with it in lab, I'm not going to assume you're familiar with it. Just break it into elements. So my elements are going to be aluminum, which is not one of the 7 diatomics, carbon, also not one of the 7 diatomics, and oxygen, which is one of the 7 diatomics. So here is my skeleton equation for that decomposition reaction. Okay, so we've gone through 3 out of the 4 types. We've gone through a single replacement, a decomposition, and a double replacement. Let's go through one of the synthesis ones. Let's go through 12. All right, so it's synthesis. I know it's going to form one compound. I have a metal and a non-metal here, so I know my compound will be ionic, so I have to consider charges. Aluminum is a 3+, oxygen is a 2-. And so I am going to balance that into Al2O3. Notice I'm balancing it based off of the charges, just like I would balance a normal chemical formula. I'm not balancing the formula off of subscripts. Okay, so for now, we're just writing the skeleton equations. We're not worrying about balancing these equations. Okay, so we have done 4. The only example we haven't done is a combustion reaction, but those are very straightforward since all hydrocarbon combustions will form water and carbon dioxide. Okay, so go ahead, send me questions. We're going to practice this together. Let me know what questions you have right now, and I will see you in class.